In front of us, in this example, we see a limit which is coming from the standard expression of the derivative. So it's definition of the derivative, basically, that has a function f of x and a number input a. But what was f of x and that number a in this scenario? I don't really understand what is happening, so maybe we should write down what we see in the writing part of this problem. Definition of the derivative. Oh, so they want me to look carefully at the formula. Limit h in the denominator, h goes to 0, f of new function is x plus h minus old function is f of x. And this is the definition of derivative. So f of x will be located here. F of x is 8, and that is the output, right? F of x plus h will be located here. F of x plus h is also an output. So how can we have two different outputs? Because we have two different inputs. The first function input is x plus h, and the second one is x. Well, you already can see the pattern. If the first function says it should be x plus h, and we have 2 plus h, then x is 2. It doesn't make sense a little bit, but it does if we write down the formula not for the general derivative f of x, and that's what I did. But if we write down the formula for the f, that's not f of x, it's f prime. But what if we write down a derivative at a? Then it will be still a limit, h in the denominator. What is the difference? Instead of x, I will have a plus h minus a, right? So f of a plus h minus f of a. Now I can see clearly that a is 2. Let's check that. How about here? F of a is 8. Well, that should match with the idea of what the function is. What was f originally? I see that the whole input 2 plus h was cubed, right? That gives me the idea that f of x is indeed x cubed. Let's check if that is true. F of x is x cubed. Thus, f of a, so that was f of x, should be what? A cubed. But we already agreed that a is 2, so it should be 2 cubed. And that matches 8 that we have over here. So we are right. The function f of x is x cubed, and input is 2. Let's check that. What is the definition of the derivative of the function x cubed? That prime, x cubed prime. That will be the limit as h goes to 0, h in the denominator. And then in the numerator, I will have x plus h, and it's going to be cubed, minus original function cubed. That will be the definition of the derivative of x cubed. Now I substitute in 2. So it's going to be 2 cubed, 2 plus h cubed, minus 2 cubed. And it's exactly what we see in front of us. And that's how you can figure out what was the function f and the input a based on the expression for the definition of the derivative of the function.